All right. Okay. Wait a minute, I don't have my book here. Just a second. All right, now I have it. All right, how are you guys? How are you guys doing? All right. Man, none of you guys are seniors, are you?
No.
Okay. Yeah. It's just kind of sad for the seniors for sure.
Yeah.
So were you guys watching the live feed?
Yeah.
Okay. So this is the permanent reality. So what I'm going to do, just because it's actually easier now that I know how to do it. I spent a long time yesterday, and it actually prevented me from getting back to what I wanted to do for you guys. But I'll do it this weekend. I want to give a couple little supplementary lectures, just short little blurbs about some details in terms of how the exponential distribution relates back to the Poisson, and how the gamma distribution is really just a generalization of that. I mean, I tried to like say that a lot of times during the lecture itself that's recorded, but I want to actually prove that. That makes sense. I think it's helpful to kind of have that in your back pocket. So I'll do some mini lectures on that, and I'll post those. But I'm going to go to a YouTube channel, Paradigm. It just is, I don't know. I mean, it seems like there's a lot fewer people doing that, and I think YouTube just knows what they're doing better than Canvas in some ways. So I'm gonna post everything on YouTube, but that means I won't be doing it. It takes twice as much time for me to do both YouTube and Canvas, and it takes significant amounts of time because the videos have to like process and everything. So I'm going to just post everything on YouTube, including things that have already been posted. I'll sort of shift everything over to that. I'm going to have, I tried to make a channel with some cute name, and it said I was going to have to change my name and my email address if I wanted to do that. So I wasn't going to do that. So my channel is literally named Adam Hammett, and there's nothing I can do about it, right? But I'll put a link to that in the on Canvas. There's I'm making like playlists for each class. So there's a playlist for combinatorics right now, because somebody in combinatorics was the first one to request that this be done. It seems far less glitchy. Actually, even the editing tools that are native inside of YouTube are way better. Because I can like split videos. I can cut stuff out easily. Apparently it used to be even better than it is now, but it's still far superior to what's going on in Ensemble. So does that make sense? Does that make sense?
Mm-hmm.
So I won't post them in Canvas. I'll send a message out detailing some of that, but I'm going to shift everything. You guys have the test.
Mhm.
That's due next Wednesday. I hope we get through everything I want to get through this semester. I'm not sure. I don't know if we will or won't, but we'll at least get to a place where I think you'll be able to slay the beast of the actuarial exam. In Providence Stats, I don't think that will be an issue at all. So the schedule's kind of out the window at this point, but that's all right. We'll still get through plenty of material. Daryl, I didn't even get to your question. You want me to pull that up before we get going? Want me to pull up that question?
Yeah.
All right. Let's do it. Here, I'm gonna pull up the I'm gonna pull up the email that you sent me. Sorry about that, Daryl. It's been kind of crazy. So this is a problem from chapter 4. Let me zoom in here, and so you can see it. I'll put it so you can actually see it. That would be a good idea. See that? This is the jury problem.
Mm-hmm.
So what Daryl is asking, and I was thinking, all right, let's help him think through this. I think, was it you, Emma, that was initially like, hey, did you send me a question about this? Was that you?
Yeah. Mm-hmm.
Question?
Yeah.
And I think this probability right here that Daryl is computing is the probability that a particular juror makes a correct decision. Yeah, remember this problem?
Mm-hmm.
And I think I think I had to correct something I saw on the paper that you sent me, right? I mean, I think that initially there was something slightly off with these numbers.
Yeah, it was with I had put down the wrong notation. So like when I did it out, I wound up multiplying the wrong decimal to the wrong like 0.65. And then I wound up getting like 0.865 instead of 0.835. That was the difference there.
So you had this 0.9 and the 0.8 were switched around.
Yeah, something was messed up with that, yeah.
Okay. Okay. Now, in the problem, remember, what did it say? Okay, so this was problem number 46, right?
Mm-hmm.
Convict a defendant. To convict a defendant, they have to get 9 out of 12. I think that might be part of the problem about what's going on here, Daryl. So even if 8 out of 12 voted to convict, guess what? That's a hung jury, my friend. So hang on a second. So the probability that the jury, okay, so you said X is the number of correct jurors, but I don't know that this is actually what you want to compute. The probability that the jury is correct, I'm not sure that that's how this is computed. Do you know why? Can someone speak to that? Like 9 or more, that would be if you were convicting them. That right, 9 or more would be like if you were convicting them and they were guilty. Yes? Right? So that's not exactly the event that the jury is correct, because they could also be correct if they have less than 9 votes. Does that make sense? Like they would also be correct if like 8 voted to convict and and 4 voted to acquit, and the person was not guilty. Does that make sense? They would also be correct in that instance. I'm not getting any feedback from you guys. Does that make sense? Do you understand what I'm saying, Daryl?
Yeah.
Okay, so do you understand? This isn't exactly the probability that the jury is correct. All you've done here is you've said 9 of the 12 jurors are correct, but I think what you need to do is you need to say, okay, yeah, 9 of them are correct and they are guilty or something, yeah, but also less than 9. Well, or you, I mean, there's any number of ways you could do this. So either 9, at least 9 out of 12 vote to convict and they are guilty. And what's the other way they could be correct? What's the other way they could be correct?
You can vote innocent if the person's innocent.
If the person, okay, the other way they can be correct is if they are innocent, and at most, how many jurors vote that they're guilty? At most, how many?
3.
No. At most 8. Because if 8 people vote to convict, and the other 4 vote to acquit, what's going to happen? Well, the jury is still going to make the correct decision. Does that make sense, Daryl?
Yeah.
Yeah. So that changes this computation. That changes this computation. So I mean, I guess I'll just leave it at that and let you kind of think through how that would change the computation. But is that how other people were thinking about this problem when they did it?
I know I was just thinking about it with like either way you need 9 of them. So I'm gonna need to go back and relook at this one.
Yeah, because you don't. Does that make sense though? You don't need 9, right? To acquit someone, you don't need 9, and you just need 8 or less to vote to convict, right? That changes stuff. But I'll just kind of leave it at that for now. That was a problem from chapter 4. It's an interesting problem. Anybody else want to provide some commentary there? Does that make sense, Emma?
Yeah, I'm just looking at what I have.
I think maybe. Did you have a 9 at least 9 paradigm in your answer as well?
So for the correct, I have like the first part for the convict like he had, and then I have plus 0.35, and then I have 1 minus a similar binomial with the 9 in it for the innocent. Would that work as well if you did 1 minus? Like the sum end with the 9 in it? If you had like 12 choose x, and then and then I've got 0.1 to the x and 0.9 to the 12 minus x instead of any other numbers. But you know what, I'll send you a picture of what I have, and then
Okay. Yeah.
that'll work, because talking about it is kind of difficult.
Okay. Yeah. But I think I remember something about like 1 minus some kind of sum.
Yeah.
But yeah. Okay. All right. What else? Questions. You guys don't have any questions? Man,
So I could have just misunderstood this, but when we're talking about the gamma distribution,
yeah.
it's the amount of time until basically the alpha occurrence, right?
If you're in a Poisson process. And
Okay.
the one thing that's confusing is the way that the parameters are set up for the gamma.
Mm-hmm.
They have the parameter alpha and the parameter beta.
Mm-hmm.
And how does beta relate to the parameter lambda?
It was 1 over lambda, right?
Yes. That's the relationship between beta and lambda.
Okay.
The reason they do that is they want the expected value. In fact, sometimes the exponential distribution itself is defined with parameter lambda. In fact, let me look at this real quick. No, right. I mean, that the reason I chose this notation is because that's how they introduced the exponential random variable in your book on page 197. They wanted there to be a clear connection between the exponential and the Poisson. So they put lambda in there. But sometimes the exponential distribution is introduced with the parameter beta instead. Okay? So, and beta is 1 over lambda, or beta is 1 over lambda, which by the way is the expected value of the exponential random variable, yes?
Mm-hmm.
The expected value of the exponential random variable is 1 over lambda, which is equal to beta. And 1 over lambda is the amount of time until the first occurrence. That kind of makes sense. Did my example make sense that I said?
Mm-hmm.
If you expect there to be 2 observations in an hour, then how long do you expect to have to wait for the first observation? 1 over 2, yeah?
Okay.
Okay, so sometimes you just have to be on the lookout. Sometimes the exponential is introduced via the random variable beta, so as to make the connection clear with the gamma distribution. But to me, it's nice that this book actually makes the connection back to the Poisson so clear. I think though that if you use Excel, hold it. Let me check again. I sorted this out before I gave the lecture yesterday, but I already forgot. So let me check this real quick. Let me share this screen. So if I ask for, so equals exponential distribution. Oh yes. Look at that. It's beautiful, right? I mean, they just straight up say lambda. It says lambda. Okay? And they mean lambda. They mean the lambda of the Poisson process.
Okay.
That would be under consideration. All right. So, and so beta is 1 over lambda. Okay. I'm currently writing a paper with Dr. Holland about some of this stuff, because to me it just it's painful how there aren't clear connections drawn out between all of these things. Gamma is really at the center of it all. The gamma distribution is at the center of everything. And then the exponential is a special case of it. And do you see the parallel between the gamma distribution and the negative binomial distribution? Like it feels like it's the same process, except the negative binomial is discrete, whereas the gamma is continuous. The gamma distribution is very important. And I did not know that until I grew up. So you have to be aware of that, okay? It's very important. It's kind of at the center of a lot of stuff, but it gets been a lot of probabilistic presentations, fortunately. You doing all right there, David? You have some coronavirus going on or what?
No, I had a cold a few days ago.
Oh, okay.
Still recovering from it. Yeah.
Yeah. All right. Well, so the lecture makes sense. I'm going to go into some details. I mean, the gamma function is amazing. I put some stuff in there about the incomplete gamma function. That's just my own stuff that isn't ever in textbooks. I don't even think I don't remember them talking about it in here. They don't have the incomplete gamma function, I don't think. I put a slide in there. I don't know if I'll talk through it very much, just in the interest of time, but I think I will at least prove some stuff about the gamma function. The gamma function, which is really it's a continuous extension of the factorial function. Do you see how that might happen? Because like gamma of 5 is equal to 4 factorial. Gamma of 7 is equal to 6 factorial. So it makes sense that, I mean, but you could compute gamma of pi, right? Which is weird. So somehow this gamma function is extending the notion of factorial to things that aren't integers anymore. So that's weird, but it's interesting. So I'll talk through some details of that. And then we'll talk about the normal distribution, and we'll be getting pretty close to some limit theorems that will close out our exploration. All right, what other questions do you have? What else?
When will our next quiz be? Because I think the next one was currently scheduled for Wednesday, and I wasn't sure if that was still the case with the exam.
No, I can give you one if I could, I could make a special exception for you, Elise, if you're really just.
I'll pass on that. Thank you.
I'll just let you guys work on the exam for now.
Okay.
We'll sort out. I'll keep feeding information to you as the timetable unfolds here. I don't think I'm going to attempt to try to like make a new schedule or anything like that. We'll just kind of take it as it goes, and I'll keep you informed as good as I can.
Okay.
I don't know. I think my original plan was to try to get at least close to chapter 8. I don't know if I'm going to be able to do that, but for sure I'll at least get through the information that you need to succeed on the actuarial exam. By the way, I mean, do you guys know about, and what is this website? Have you guys seen it, the website that is the recommended one? I was going to show you this at some point, but let me see. I'll pull it up here. This is an online thing. Coaching Actuaries.
Mhm.
So you've heard of that?
Yeah, I made an account with them over spring break and did my first practice exam.
Okay, how'd you do?
I got 9 out of 30 questions, which I thought was pretty good considering like 4 of them were like, it's a Poisson distribution. And I was like, we're so close, but haven't quite covered that yet. So I think I could probably do significantly better now that we've covered that.
Yeah. So if you go here, I mean, it's very helpful. There are certain levels of membership that you can purchase to the website. I've talked to several people that have done this before. man, I'm trying to, pricing. Here it is. Are you guys seeing what I'm doing right now?
Mhm.
Mm-hmm.
I don't think, I think that, so I was talking to Josh Kochsmeyer about this. You guys probably don't even remember him. And Elliot McElroy also. I think they said they did like 60-day or 90-day or something. But if you buy the 180-day, they give you a pass guarantee. So there's like a pass guarantee. I don't know how the refund situation works, but I think that's what's going on. So, and you get a special deal if you're currently a student. If you're not a student, if you're working for an actuarial firm, they will actually pay you to work for them while you study, and they'll like pay for the exam. That's good. Josh said he never bought the Adapt and Learn like complete exam prep package. He always just did the dynamic practice exams and then like looked at other things. But I mean, if you want like a manual to help you study, and I think they might have some little tutorials and things like that. That's sort of expensive, but I guess you could do that. Let's see, what happens if it's 90-day, 478, 143? Are you a student? What if I say yes? Oh man, look at that. Amazing. The price like dropped dramatically. That's what happens when you get old. 180-day. Oh man, it might actually be worth it to do Adapt. And I mean, look at that. It's only like 66 bucks more or something. It's a pretty good deal, I guess. So something to consider. Apparently it works really, really well. And I think they say that once you're getting like I don't remember what it is.
I think it's if you hit like a level 7 on their website, they say you've got a really good shot at passing.
Yeah. If you get like a level, yeah, that's right. And they'll say there's like a 98% chance you're going to pass the test.
Mhm.
But take it right now. They keep track of all that for you. So it's pretty nice. And they did the same thing. So theory of interest, we tailored that exam to prep you for the FM exam. And it's the same website. So I think Annie Lowe, you know Annie? I think she went and passed them. But she didn't take any classes, so that's kind of funny. I think that she just had taken the material at some point, like when she was in China or something, and was able to just study and pass. But yeah.
Stuart White's passed a couple too.
Who has?
Stuart White.
Oh, okay.
He took FM earlier this semester.
He took FM. He hasn't even taken theory of interest.
That's what I said too, but
Okay, yeah. But they're not as bad as you might think. So I haven't looked at it in a while, but I think you have the vast majority of material, even at this point, that you would probably need to be mildly successful at this point. They don't tend to like invoke a lot of central limit theorem applications, but they are going to want you to be able to use like the standard normal distribution to do some things. But they're obsessed with the Poisson, they're obsessed with the exponential. Those are the big two. So questions, any questions? So there are certain distributions I will just flat out skip, like the Weibull distribution, the beta distribution, the Cauchy distribution. I will just flat out skip those because a lot of those are just really kind of super special cases. If I had to pick one that I would say is, you know, more important than others, then those ones I just mentioned would probably be the beta distribution. But I'm just going to stick to the ones that I know are the most important. So, yeah. You guys are out of questions? Have you looked at the test yet? Come on, David.
I'm sorry.
Hey, some exciting problems on there.
Okay.
So, I think it's a very reasonable exam though. So should be able to do all right. So is this working for you? Like the video, I mean, I you know, the only thing I can do is get feedback from you. And I mean, if it stinks, you got to just tell me that it stinks, all right? So, so otherwise I'm just going to keep doing stuff that stinks. So is this working all right? Like just posting videos, using this time to get questions answered. You can come to office hours and ask questions. Yeah?
Yeah.
All right. Yeah. We're just flying by the seat of our pants here. I'm going to go to an exclusive YouTube paradigm, and at which point I will cease to post videos in Canvas any longer. That will be the new mode. Well, hey, I don't want us to just sit here and stare at each other. You guys have plenty of other things to do. I'll let you guys get to it. Is that you guys
Thank
done?
you, Dr. Hammond.
Yeah.
You done? All right. Well, let's be done then.
All right.
I'll see you guys later.